Hi everyone, today we are going to learn how to solve triangles when they are not right triangles. So all the way up until this point, we have learned how to work with right triangles. We've worked with the Pythagorean theorem. We've learned about special right triangles, 45, 45, 90, and 30, 60, 90. We have also learned about SOHCAHTOA, and all of those rules have all corresponded with right triangles. So what happens when you don't have a right triangle and you have an acute triangle or an obtuse triangle and you want to identify a missing side length or you want to identify a missing angle? Well, there are two different laws that you're going to learn about in the next couple of lessons. The first law, which is today's lesson, is called the law of sines, and the next law is called the law of cosines. And so our goal for today is for you to use the law of sines to solve for the sides and angles of a triangle. So this works for any triangle. So please know that this works for any triangle. Because not all triangles are right triangles. So the law of sines is very useful for solving. Now remember that to solve a triangle is to identify all of the missing sides and missing angles of that triangle. So it's very useful for solving any triangle. And the rule goes like this. Little a is going to be divided by the sine of angle A. Little b is divided by the sine of angle B. And little c is divided by the sine of angle C. So what you're going to have is you're going to have a triangle. And all capital letters, A, B, and C, will represent angles. And all lowercase letters will represent sides that are opposite. So the side that is opposite of angle A will be called side A. The angle that is opposite of, the side that's opposite of angle B will be called side B. And the angle C, the side opposite of it, is going to be called side C. So the opposite side is going to have the letter that represents the angle that it's opposite of. So we are talking about a side opposite of angle A, it'll be called little a. So what we have here is a proportion, and we learned back in Unit 6 how to solve proportions, and we've actually been working with proportions in order for us to identify missing side lengths. So what you want to do here is you want to match two, you're going to identify your information, and you're going to match two of your fractions together. So you might set up an equation that might be little a divided by the sine of angle A, and you might set it equal to little b divided by the sine of angle B. You might have an equation where it's little a divided by the sine of angle C, of angle A is equal to little c divided by the sine of angle C. Or you might end up with little b divided by the sine of angle B is equal to little c divided by the sine of angle C. Now, how you know which proportion you're going to set up is going to be based on the information that's given to you. And one of the little tricks for remembering when to use the law of sines is when you can easily identify two of a kind. So when you can easily identify two of a kind, use the law of sines. So what does two of a kind mean? Well, if you know angle A and you know side A, you know two A's. And if you know angle B and you want to find little b, you have two B's. So it just depends on the information that's given to you, but typically it will be very easy to identify two of the same letter. So let's go ahead and look at example number 1. For example number 1, we want to find little c. So little c, notice it's straight across from angle C, which is 105 degrees. So we're going to identify the other information that we know. We know that angle B is 35 degrees and the side opposite of it is 7. The side opposite of it, we're going to call that little b because it is opposite of angle B. So the proportion that we're going to use to identify what C is we're going to use little b divided by the sine of angle B equals little c divided by the sine of angle C. We know two of a kind. The two of a kind is angle B and little b, and this will help us to identify what little c is. So I'm going to plug in all of my given information in order for me to solve or to identify c. So little b, that is 7. So I'm going to write 7 divided by the sine of angle B, and angle B is 35 degrees. That's going to be equal to little c, which I do not know, divided by the sine of angle C, which is 105. At this point, to find c, we're going to do cross product. So I'm going to write c times the sine of 35 is equal to 7 times the sine of 105. To get c alone, I'm going to divide both sides by the sine of 35. And what we're going to do is we're going to put this into our calculator exactly as we see it to find what little c is. So in your calculator, if you have a calculator, that might be a good thing. So at the beginning of this lesson, or if you need to pause the video right now to take out a calculator, that might be a good thing. So I guess I'll let you pause for a second to go ahead and get yourself situated. All right, hopefully you have a calculator by now. So verify that your calculator is in degree mode. So you press mode and verify that it's in degree mode, or look at your scientific calculator and make sure you can see a little d. And I'm going to put in 7 times the sine of 105, and I'm going to close my parentheses. Then I'm going to write divided by the sine of 35, and I'm going to close my parentheses. And when I press enter, I want to round my answer to the nearest hundredth. So I'm going to end up with 11.79. So C is equal to 11.79, and if we had units, we would write down units, and that is our answer. Let's go ahead and look at example number 2. For example number 2, they're asking us to find the measure of angle B. So please note that whenever we're working with sides, we want to round our sides to the nearest hundredth, and whenever we're working with angles, we want to round to the nearest whole degree. So I can write that down for you guys if you need. So sides are going to be to the hundredth, and angles will be the whole number. Round to the nearest whole number. All right, so for this problem, we know what 63 degrees is. 63 corresponds with angle C, and I know that opposite of angle C is 5.5. So 5.5 is little c. Angle B is what I want to find, and I know what little b is. That's going to be 4.7. So I'm going to set up my proportion using A's and B's. I'm sorry, using B's and C's. So I'm going to use B divided by the sine of angle B is equal to little c divided by the sine of angle C. So little b is 4.7, and I'm going to divide it by the sine of angle B. This equals little c, which is 5.5, divided by the sine of angle C, which is 63. At this point, I'm going to do cross product, and I end up with 4.7 times the sine of 63 is equal to 5.5 times the sine of angle B. I need to get the sine of angle B alone, so I'm going to divide both sides by 5.5. And now I end up with 4.7 times the sine of 63 is all over 5.5 is equal to the sine of angle B. Now, in order to undo sine next door to B, we have to use sine inverse. So I'm going to take the sine inverse of both sides. And I'm going to put that into my calculator exactly as I see it. So I'm going to press second sine, so I end up with sine inverse. And I'm going to put 4.7 times the sine of 63, closing my parentheses, then dividing by 5.5. I'm going to close my parentheses to establish I'm taking the sine inverse of that entire quantity, and then I'm going to press enter, and I end up with 49.58. So rounding that to the nearest whole degree, that's about 50 degrees. So the measure of angle B is equal to 50 degrees. If at any point while you're watching this video you need the video to be paused, please feel free to just say I need the video to be paused so that you can get yourself caught up. I have no problem with that. All right, let's go ahead and move on. Example number 3, I would like you to please go ahead and try this one on your own. This is going to be your turn, but I'll help you get your triangle set up. So it says you are given that little b is equal to 7, the measure of angle C is equal to 53 degrees, and the measure of angle B is equal to 44 degrees. We want to find what the length of AB is. So the triangle that we're going to draw is going to be just a regular old triangle. Any triangle that you draw is absolutely appropriate. And I'm going to call this A and B and C. And little b is going to be right across from angle B, and we're going to call that the number 7, because little b is equal to 7. The measure of angle C is 53 degrees, so I'm going to put in 53 degrees. And the measure of angle B, that's equal to 44 degrees. And we want to find the length of AB, and AB is right across from angle C. So AB is really identifying what little c is. So we're going to be, since we know 2 of a kind, 2 of our b's, we're going to work with the formula little b divided by the sine of angle B is equal to little c divided by the sine of angle C. So please go ahead and fill in your information and pause the video so that you can try this problem on your own. And when you have an answer, go ahead and restart the video and we'll see how well you did. All right, so we have 7 divided by the sine of angle B, which is 44 degrees. This is equal to little c, which we do not know, divided by the sine of 53. So we're going to do cross product, and we end up with 7 times the sine of 53 is equal to little c times the sine of 44. To get c alone, I'm going to divide both sides by the sine of 44. And I end up with little c is equal to 8.05. And that is our answer. So hopefully you did a good job and you were able to get the correct answer with ease. And if you didn't, then please feel free to email me, or we can certainly talk about this upon my return. Example number 4, it says given that A is equal to 22, B is equal to 9, C equals 19, and the measure of angle A is equal to 97, find the measure of angle C. Draw a picture. So what I'm going to do is I'm going to draw an obtuse triangle, because 97 degrees is larger than 90 degrees, so it needs to be obtuse. So here's my obtuse triangle. And I'm going to put my angle A right here and call it 97 degrees. Little a is across from it, and I'm going to call that 22. So little a is 22. I'll call this B, and I'll call this C. B, that's going to be equal to 9, that's little b, and little c is equal to 19. And that's straight across from angle C. So we want to find the measure of angle C. So this B equals 9, that's extra information that we really do not need to know. The proportion that we're going to set up, since we know 2 of a kind, we know an A and an angle A, we're going to use the proportion little a divided by the sine of angle A equals little c divided by the sine of angle C. You do not need to set up this proportion or write this proportion using letters every time, but while you're learning, it might be helpful to have it written down. I'm just putting that out there. So I'm going to put 22 divided by the sine of 97, since that's little a divided by the sine of angle A, equals little c, which is 19, divided by the sine of angle C. And I'm just going to write the letter C. At this step, I'm going to do cross product. And I end up with 22 times the sine of angle C is equal to 19 times the sine of 97. At this step, I need to get the sine of C alone, so I'm going to divide both sides by 22. And I end up with the sine of angle C is equal to 19 times the sine of 97 divided by 22. I'm going to get the sine away from angle C by taking the sine inverse of both sides. The sine and the sine inverse cancel away, leaving me with simply the measure of angle C is equal to, and I'm going to show you once again how to put this into your calculator. So we start off by doing second sine, and then I'm going to write 19 times the sine of 97, and I'm going to close my parentheses. Then I'm going to write divided by, so the division button, and then 22. Closing my parentheses, I end up with 59 degrees. So the measure of angle C is equal to 59 degrees. We have one more example and then we are done. So an airplane is spotted by two observers who are 1,300 feet apart. So we have observer A and observer B, and they are 1,300 feet apart. As the plane passes over the line that's joining them, each observer takes a sighting of an angle of elevation to the plane. So you'll see this on the picture. So one has a 40-degree angle, the other has a 35-degree angle. We want to use the law of sines to find the distance from observer B to the airplane to the nearest hundredth. So we want to go from observer B to the airplane. And since that's across from angle A, we want to essentially identify what little a is. 1,300 is across from angle C, but I do not know what angle C is. So we have to use our 180-degree rule in order to find what the measure of angle C is. So that's our first thing. We need to find what the measure of angle C is. So the measure of angle C is going to be equal to 180 minus 40 minus 35. And 180 minus 40 minus 35, that is equal to 105 degrees. So I'm going to put in 105 degrees. Next, I need to find what little a is. So I'm going to be working with the proportion little a divided by the sine of angle A equals, my two of kind are little c and angle C. So I'm going to write little c divided by the sine of angle C. So I'm going to write little a divided by the sine of 40, because that's what what angle A is, equals little c, which is 1,300, divided by the sine of angle C, which is 105. At this step, I'm going to do cross product, and I end up with little a times the sine of 105 equals 1,300 times the sine of 40. I'm going to divide both sides by the sine of 105. And when you put that into your calculator, so if I were to put that into my calculator, that's going to be 1,300 times the sine of 40 divided by the sine of 105. That equals 865.10. So that's 185.10 feet. And that is our answer, as well as the end of today's lesson. So your homework for today is to work on the Law of Sines worksheet, and then also feel free to watch the next video over the law of cosines if you would like. Otherwise, I hope you have a wonderful day, and I will see you soon. Please feel free to email me if you have any questions over anything.